A ball of mass m attached to a string of length L moves in a circle in a vertical plane as shown above. At the top of the circular path, the tension in the string is twice the weight of the ball. At the bottom, the ball just clears the ground. Air resistance is negligible. Express all answers in terms of m, L, and g. A bit. Determine the magnitude and direction of the net force on the ball when it is at the top. B bit. Determine the speed V naught of the ball at the top. The string is then cut when the ball is at the top. C bit. Determine the time it takes the ball to reach the ground. D bit. Determine the horizontal distance the ball travels before hitting the ground. Now, he is asking us to find out the magnitude and direction of the net force on the ball when it is at the top. See here, this is the force diagram. The ball is at the top. When the ball is at the top, both the tension and gravity are acting downwards. That means towards the center. So sigma Fi is equal to Ft plus Fg. And then he is saying that the tension in the string is twice the weight of the ball. Therefore, F tension is 2 mg. We know Fg is equal to mg. And then tension is equal to 2 times the weight of the ball. Therefore, it is 2 mg. Okay, I write here. Fg is equal to mg. And then F tension is equal to 2 mg. This is given in the problem. So the total is 3 mg. This is the answer for the first bit. Next, determine the speed of the ball at the top. We have to find out the speed of the ball. So the speed of the ball is, to find out the speed of the ball, we have to write the force equation. What is the force equation? Sigma Fi is equal to Fc, because the what are the forces acting are? Those forces contribute to the centripetal force. Okay, and we know Fc is equal to mv square over r, and then the total force just now we calculated 3 mg. Therefore, 3 mg is equal to mv naught square over L, because here he is saying that it is the L, radius is the L. Therefore, we will use the same abbreviation. Okay. So mv naught square L. Here I write mv naught square L. Therefore, this is mv naught is equal to square root of 3 Lg. M cancels out, and then we are left with this one. Okay, this is the answer for the second question. Now the third bit. When the ball is at the top, the string is cut. Now we have to find out when the string is cut, what happens? The ball falls down. Am I right? It will not negotiate the circle, but it takes the projectile motion. Am I right? When it is the projectile motion, then we have to use the kinematic equation. So kinematic equation delta y is equal to VAT plus half AT square. Here the ball has only horizontal velocity, no vertical velocity. Remember, the ball has no vertical velocity. It has only, because the tangential velocity in the circular motion, when the ball is at any point on the trajectory, it has the velocity is always directed tangential to the circle. Okay. Here the velocity is at the top point, it has the horizontal velocity. Therefore, no vertical velocity. So vertical velocity is equal to 0. Here we are writing the vertical motion. Am I right? So delta y is equal to vi by t plus half at square. This is equal to vi y is equal to 0, because y dimension velocity is equal to 0. So the first term goes off, and then acceleration is equal to g, acceleration due to gravity. So substituting that one, and then delta y is equal to 2L. How 2L? The radius is L. It has to fall to reach the ground. It has to fall the 2 length. No, that means the diameter of the circle. So the diameter of the circle is 2L. Therefore, delta y is equal to 2L. Therefore, 2L is equal to half gt square. From this, t is equal to 2 root L by g. This is the answer for the C bit. Next, D bit. Determine the horizontal distance the ball travels before hitting the ground. So horizontal distance is equal to Vt. And we know V is equal to square root of 3 Lg. And then T is equal to 2 root L by G. These two we already calculated. Substituting those values in this equation, delta x is equal to Vt, we get delta x is equal to 2 root 3 L. This is the answer for the third bit, last bit. Okay. So this question is mainly based on the uniform circular motion. You should remember that the velocity at the top point is horizontal because this is the ball is in the moving in the um, anti-clockwise direction or counterclockwise direction. Therefore, the velocity is directed towards left, that too tangential to the path. Therefore, it takes the parabolic path and then it is a projectile motion. When the object is in projectile motion, we have to use the kinematic equation. So kinematic equation delta y is equal to v by I t plus half at square. And then obviously here this velocity is only horizontal velocity. Vertical velocity is 0. It has no vertical component at all at this point. Therefore, VIY is equal to 0. Therefore, the first factor goes off 0. This becomes 0. And then the object is under free fall, except gravity, no other force is acting. Therefore, we have to consider the free fall acceleration. So free fall acceleration is nothing but acceleration due to gravity g. And then how much distance it has to travel vertically? 2 times the radius. 2 times the radius means L is the radius and then 2 times the radius is 2L. Therefore, delta y is equal to 2L. And then substituting these values, you will get the t value. Once you calculate the t value, b value already calculated. Therefore, you can easily calculate the delta x. Hope this helps. Thank you. Bye bye.